Right now, like as you listen to this exact sentence, there's an invisible war raging inside the networks of the world's biggest banks.
Yeah, banks, hospitals, major power grids, it's happening everywhere.
Exactly. And by the time you take your next breath, an autonomous piece of malware will have shapeshifted to evade a scanner
Right. It'll have probed a cloud environment thousands of times.
and triggered an AI countermeasure that locked down a server. And the crazy part,
Mhm.
all of this happens without a single human being ever knowing it took place.
Not a single alert pops up on a human screen until the battle is already over.
It's wild. So if you want to understand how the world actually operates today, you need to just completely erase that outdated image of cybersecurity.
Yeah, the whole hacker in the hoodie thing.
Right. The hacker in the hoodie is gone. The
Yeah.
stressed out IT guy furiously typing in a terminal, gone.
They've been replaced by algorithms.
Exactly.
Yeah.
Today we're doing a deep dive into this fascinating breakdown from the AI 365 blog. It's titled AI versus AI, Artificial Intelligence and the Invisible Cybersecurity War.
It's a really sobering read, honestly.
It really is. And our mission for this deep dive is to pull back the curtain on this new reality. We're looking at a fully automated algorithmic battlefield.
And it's operating at speeds that, frankly, entirely exceed human perception.
Right. So to truly wrap our heads around this invisible machine war, we first have to understand why humanity was permanently benched.
Yeah, why we were removed from the front lines in the first place.
Okay, let's unpack this. Because early defenses were basically built for static risks, right?
Exactly. The old security architecture relied on known threat signatures, basic firewalls, manual patch management.
Stuff an actual human could monitor.
Right. The assumption was always that threats were identifiable and human engineers had the time to analyze a vulnerability, manually write a rule to block it, and deploy it.
But the internet obviously didn't remain a series of easily defensible static fortresses. It decentralized into this massive, borderless data ocean.
We're talking cloud environments, remote endpoints, thousands of third-party APIs.
Right, so relying on a traditional firewall today is like, well, it's like trying to protect a massive, sprawling city with a single medieval drawbridge.
That's a great way to put it.
Yeah, I mean, it might secure one specific entry point, but it completely ignores the millions of subterranean tunnels and airspace corridors everywhere else.
And the attackers figured that out very quickly.
But I have to push back a little on the core premise of human failure here.
Okay, go for it.
Was a collapse of human-led defense purely a matter of these data oceans becoming too vast? Or were the human defenders themselves simply too slow to recognize the new threats?
Well, it's really the compounding effect of both. It's an issue of scale intersecting with velocity.
Scale and velocity, okay.
Yeah. The sheer volume of telemetry data generated by a modern enterprise network, it became impossible for any human team to manually parse.
There's just too much noise.
Exactly. And simultaneously, attackers automated their discovery processes. They deployed scripts to scan for structural vulnerabilities globally.
Before humans could even write a patch.
Right. The human-led model didn't just struggle, it totally collapsed under the physics of the modern internet. We just can't perceive anomalies fast enough.
So, because human defenders proved to be, biologically incapable of keeping pace, attackers realized they didn't need to manually hack systems anymore.
They could just unleash autonomous algorithms to do their dirty work.
Exactly. The AI 365 article systematically breaks down this offensive arsenal, what they categorize as the sword.
And the underlying mechanics are terrifyingly sophisticated.
They really are. They detail three major offensive weapons. Let's start with the first one. Hyper-realistic social engineering.
Right. Attackers are leveraging advanced machine learning to engineer incredibly elusive weapons.
Well, we need to be clear. This is light years beyond a poorly worded phishing email from a fake prince.
Oh, absolutely. We are looking at autonomous agents utilizing large language models to craft flawless, contextually perfect communications.
It's so creepy. The article mentions they scrape a target company's public communications, ingest org charts from LinkedIn, and analyze internal emails.
Yeah, to mimic the exact cadence and vocabulary of a specific executive.
And then there's the deepfake audio and video. I mean, imagine getting a FaceTime call from your CEO urgently authorizing a wire transfer.
The facial microexpressions are perfect. The vocal inflection is indistinguishable from reality.
But it's an entirely synthetic AI construct. It's wild. Okay, so the second major offensive weapon is morphic malware.
Right. The technical payload delivery systems have evolved just as radically as the social engineering.
Here's where it gets really interesting, because To grasp this, you have to think about legacy antivirus software. It basically acted like a digital wanted poster, right?
Exactly. It scanned a computer's file system for specific known digital signatures, basically the static cryptographic hashes of previously identified malicious code.
But morphic malware completely shatters that wanted poster paradigm.
Yeah.
Instead of being this static, identifiable binary, it's a digital chameleon.
It utilizes dynamic obfuscation.
Right, so every time the malware moves across a network, it rewrites its own underlying code. It swaps out registers, inserts fake benign code.
But the malicious logic remains perfectly intact.
Wait, I have to stop you there. Because if the malware is constantly changing its signature in real time, like a chameleon, how can any security system possibly know what to look for?
What's fascinating here is that this exact problem forced the cybersecurity industry to entirely reinvent how a shield works.
Because scanning for signatures became mathematically impossible.
Right. They had to pivot away from looking for known signatures and start looking at broader behaviors.
Okay, but even if that morphic malware hides from scanners, it still needs a way to break into the network. Which brings us to the third weapon, machine speed exploitation.
This is where attackers deploy autonomous tools that just relentlessly bombard enterprise perimeters.
They scan networks and find zero-day vulnerabilities in milliseconds.
And what truly stands out is that these AI tools use reinforcement learning. They actually learn from their own failures on the fly.
So they try to break in, fail, analyze why they failed, rewrite their exploit, and try again in the blink of an eye.
Thousands of times per second. It elevates offensive AI from a mere tool to an active learning adversary.
So facing this swarm of self-mutating, self-learning weapons, defenders had to deploy the shield.
Right, the AI-driven defenses. Because the offensive side became morphic, the defensive side had to become entirely predictive.
Predictive anomaly detection.
Exactly. Instead of looking for known viruses, the AI monitors the baseline network behavior. It mathematically maps the normal behavior of every user and every server.
So it's kind of like imagine a highly paranoid security guard.
Okay, I like this.
He doesn't memorize a list of known criminals.
Yep.
Instead, he just intensely studies the people who work in the building. And one day, he notices that an employee's shadow is moving half a second too slow.
Wow, yeah, it flags subtle deviations that a human analyst would completely miss.
Right. It doesn't need to know the name of the malware. It just mathematically recognizes that something is wrong.
And recognizing the anomaly is only half the battle. The critical advantage of the AI shield is instant incident response.
Because if a human has to respond, it takes hours.
Exactly. Automated platforms can isolate compromised servers in fractions of a second. The AI detects the anomaly and instantly quarantines the infected server before the malware can spread.
But there are vulnerabilities here, right?
Yeah.
Because adversaries probe these models, and this brings up the whole issue of false positives.
Yes, because the defensive AI is so paranoid, it inevitably generates a high volume of false positives.
Like the paranoid guard tackling an employee just because they bought a new brand of coffee.
Exactly. And investigating those false positives falls squarely on the shoulders of the remaining human security teams. The alert fatigue is staggering.
So the AI stops the high-speed threats, but the humans are just crushed under the sheer volume of alerts.
It pushes the human team to the brink of exhaustion.
Okay, so we've established the sword, the shape-shifting attacker, and the shield, the hyper-vigilant defender. When they clash, it creates this invisible war.
A relentless cat-and-mouse game with very real-world consequences.
Which brings us to a terrifying concept in the article: adversarial machine learning.
This is the absolute bleeding edge of the conflict. It's where attackers deliberately trick defensive models into misclassifying malware as safe code.
Data poisoning.
Yes.
Yeah.
They deliberately inject subtly manipulated data into the network. They aren't trying to breach the system immediately,
They're just slowly tricking the AI's algorithm.
inch by inch, until the AI accepts malicious activity as the new normal. So defenders have to constantly retrain their algorithms to spot the deception.
This raises some profound ethical and legal questions.
This raises an important question, absolutely. Think about the chilling reality that algorithms are making autonomous decisions that could affect physical infrastructure.
Right, like cutting power to a hospital.
Or freezing a banking system in milliseconds. Who is accountable if an automated defense accidentally shuts down a hospital's life support servers to stop a virus?
Because it just calculated that a total blackout was the fastest way to kill the malware. It didn't know patients would suffer.
Exactly. The geopolitical and legal frameworks we have right now are entirely inadequate for assigning liability in these scenarios.
It's terrifying. As a listener, you realize we are completely at the mercy of how well these two competing AIs understand reality.
We really are. We're deploying these highly autonomous systems without resolving the fundamental ethics of machine accountability.
So what does this all mean? We've talked about the scary macro level stuff, but the AI 365 article actually gives some actionable takeaways.
Right, because operating in a state of perpetual technological paralysis isn't a strategy.
The first takeaway is that complacency is your greatest vulnerability. Static security is dead. The article actually says awareness is infrastructure.
That's a great line. You have to assume a breach is an inevitability, not just a possibility.
And the second point is shared accountability. It's no longer just an IT problem.
Because of that AI-driven social engineering we talked about.
Right. Everyone from the C-suite to the interns must practice good digital hygiene. Your voice and your likeness are actively being modeled by the sword.
If we connect this to the bigger picture, it underscores the absolute necessity of continuous learning.
Staying AI literate.
Exactly. Keeping your team AI literate is the best defense against an adversary that learns at the speed of light. In a world where machines guard the gates, staying stagnant is an open invitation to disaster.
We built these machines because our biological reaction times were too slow, but now we're sprinting just to understand them.
It's a paradox for sure.
Well, I want to thank you all for joining us on this deep dive. We've unpacked the failure of static defenses, morphic malware, and predictive AI shields. But before we sign off, I want to leave you with one final, unexplored thought inspired by today's text.
Oh, all right.
So we talk about adversarial machine learning, tricking AI into thinking malware is safe code by slowly redefining the baseline, right?
Right, the data poisoning.
Well, think about this. If these AI shields are constantly redefining what normal baseline behavior is, could a sophisticated attacker subtly manipulate your company's network over time? Not to slip in malware, but until the AI shield decides that you, the legitimate human employee, are the anomaly.
Oh, wow.
Could an algorithm permanently lock you out of your own digital life just because an invisible attacker tricked it into thinking your normal behavior was suddenly a threat? Something to think about. Thanks for listening.